In this video, we're going to talk about scientific notation and really how to write numbers in scientific notation. In the next video, we'll find out how to actually do mathematical operations like add, subtract, multiply, and divide using scientific notation. But here, we're just going to talk about what it is first and then how to write numbers in this format. And that really all scientific notation is a different way to write numbers, a different format you have. And so the way that you're going to recognize scientific notation is there's one part that has a number between 1 and 10. And so you have a number between 1 and 10, so there's only one number to the left of the decimal point times 10 to a power, or an exponent. If you don't know what exponents are, you need to watch the video on exponents. So this is a number written in scientific notation. You have a number on the left here between 1 and 10 times 10 to something. That is the format for all numbers that are in scientific notation. So there's really no magic to this. To find out what this number is in the way that we would normally see it, you can just do a multiplication. This is a multiplication. So you can do 3.592 times 10 to the third. And if you know what 10 to the third is, it's 1,000. And so you can do this multiplication and you get 3459.2. So these two are the same. They're just written in different formats. This is how we normally look at numbers, 3,459.2. This is that same number written, though, in scientific notation. Now, we really use scientific notation when we're trying to do very large numbers or very small numbers, but here's just an example of how it might look. So another way that you'll see this, again, a number between 1 and 10, this won't vary. But here we have a negative exponent. Again, if you don't know what a negative exponent is, you need to watch the exponent videos because it doesn't mean it's a negative number. What a negative exponent is, so again, we're just going to do the multiplication. 10 to the negative fifth is really 1 over 100,000. And so if you do that multiplication, you are going to get 0.1234 zeros and then 4683. So again, this number written in scientific notation, those are the same. Here we've just done the multiplication. But if you look at the relationship between this number and how we wrote it in scientific notation, and this number and how we wrote it in scientific notation, you're going to see that there's actually a shortcut where you don't have to actually write out and do the multiplication. You can see that the exponent here is a key to this shortcut. So the difference between 3.4592 and 3,459.2 is that there's a difference in the decimal point, three spots, and you'll notice there's a 3 on the 10. So we just moved this decimal point over 3 spots and we got the number. Now similarly, you can see that the difference between these two numbers is that we've moved the decimal place over 5 spots. 1, 2, 3, 4, 5. And so in order to not go through all this, you can see that if you have a positive exponent, you're going to move the decimal spot to the right that many times. So we take 3.4592 and move it over 3 spots. 1, 2, 3. And we get this number. Now if you have a negative exponent, we're going to take this number and move the decimal point to the left that many spots. So here we're going to go to the left 5 times. 1, 2, 3, 4, 5. and that's where the decimal point is. But you'll see there's no numbers here, so we're going to fill that in with zeros, and then you can put a 0 out in front. So you have 0.1, 2, 3, 4 zeros, and then a 4, 6, 8, 3. So I'm going to pause and we'll do a couple of examples. So let's look at this example. We have 7.486 times 10 to the 6th. All we do is take 7.486, and we're going to move the decimal point. Since this is a positive exponent, we're going to move it to the right. 1, 2, 3, 4, 5, 6 spots. There's the decimal point. Now again, we don't have numbers here, so we're just going to fill them in with zeros. So we have 7, 4, 8, 6, 0, 0, 0, which is 7,486,000. Let's do one with a negative exponent. 9.82 times 10 to the negative 6th. So we're going to take 9.82, start at the decimal point, and move it over to the left now 6 spots. 1, 2, 3, 4, 5, 6. Put the decimal point. We fill these in with zeros. 1, 2, 3, 4, 5 zeros, and we can put a 0 out in front. So we have 0.1, 2, 3, 4, 5 zeros, 9, 8, 2. So again, here's a shortcut of how you are given a number written in scientific notation and write it as a number that we would normally look at. Positive exponent, move the decimal to the right. Negative exponent, move the decimal to the left. Now, let's say we're going the other way, where they give us a number, and now we have to figure out how to write it in scientific notation. So here's an example where we're given a number, and the question is, write this in scientific notation. Well, these are commas here, not decimal points. So we have a rather large number here, and we need to write it in scientific notation. Now this is a whole number, and so remember, with a whole number, there's always the decimal point is at the end of it. So that's where your decimal point starts. So all we're going to do is move that decimal point until there's only one digit to the left of it, because remember, in scientific notation, the first part of it, the first number is between 1 and 10. So in this one, we'll move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. When we get to the 9th spot, there's only one digit to the left of it, 2, so we stop there. So we have now 2.8, and there's all those zeros after it, but I'm not going to write those since they're zeros. 2.8 times 10, how many spots did we move it? 9. So we have 2.8 times 10 to the 9th. That's how you write scientific notation for that large number. So you can see, as you have large numbers, the reason we write it in scientific notation is just because it's shorter to write. Let's do 0. There's 7 zeros here. 372. Okay, so now we have our decimal point here. So remember, if it's a very large number, you're going to have a positive exponent. It's a very small number, you're going to have a negative exponent. And so here we have to move it to the right in order to get a digit between 1 and 10 to the left of the decimal point. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8. When we've moved it to the 8th position, we now have a digit other than 0 to the left of the decimal point. So we're going to stop. So 3.72, I'm just writing this down, times, and how many times did we move it? We moved it 8 times. But we moved it to the right, so this is a negative exponent. So in order to not get confused about, oh, should it be a positive exponent or negative exponent, just remember, if you have a very large number to start with, you're going to have a positive exponent. If you have a small number that you start with, like this number, I mean, it's not even, it's less than, 1, then you're going to have a negative exponent.